One of the most important topics in all of chemistry is that of dimensional analysis. And this type of math can be used in a variety of areas of your life, whether it be buying groceries or just carrying out normal everyday tasks. So we need to have sort of a system for this. Now, what we're doing in dimensional analysis is basically we're solving math problems in chemistry. Just as we were doing with the prefixes, we were switching from one type of prefix to another. We could do that with any kind of unit. So for example, there are 12 in a dozen, or there are 454 grams in a pound. Those types of conversions are things that we can use to get answers in a particular unit that we want. Another way that you could do this in the grocery store, as I mentioned, is figuring out how many cents you might have to pay for a particular ounce of some type of food. And if you can get everything in the same unit, then you can compare them and tell which one's really cheaper. So there's lots of ways to use dimensional analysis. You may know this as picket fences or, just chemistry math. So we want to systematically go from one unit to the other when we're doing these types of things. You have to know what the conversion factors are. So if you don't know it, look it up or find where that information is. So here are some guidelines I'm going to give you. But here is the biggest guideline I can give you, and that is to use your units to help guide you in this process. I have seen so many people struggle because they refuse to write down units. The wonderful thing about chemistry math, if you write down your units, it's like you get free cheating. Not really cheating, okay? But it's like it tells you what to do. If you don't write down your units and you try to do things in your head, I guarantee you are going to mix things up. So please, I'm begging you, write down your units. So here's how we do things. I teach it by going by the units because the number that goes with the units, yes, that stays there, but that's not what we're focused on. Because if you can focus on the units, the numbers will fall into place. So start by identifying the units of what is known. So like, what is your data that you're given? I have 2.3 pounds. That would be data that you're given. And your units are pounds. And then it might say, how many grams is this? So you need to identify what is unknown. So I don't know how many grams I have. And we need to have conversion factors between those two. So that's what I mean. Identify conversion factors, or what units are equal. They're not always exactly equal. That's a whole different question, but you need to know what that is for both the knowns and the unknowns. And many times it's not just a conversion of something like grams to pounds. It's something that you have to know several different conversions for. So you start with the known value. This is a big thing that I certainly recommend. So start with where it is the data is that you're given, because that's the easiest starting point. If you have one with a single unit, that's even better because it's so much easier to cross things out. And then you just start multiplying by conversion factors so that the denominator on the bottom cancels with the previous numerator until you get the desired unit. Big thing here though, make sure the numbers stay with the appropriate units. So all of those inequalities that we dealt with prefixes, still equal to 1. So whatever's on top divided by whatever's on bottom should still be equal. And it doesn't matter which one's on top or on bottom, but make sure that you keep the numbers with the unit appropriately. And then once your units cancel out, there's your roadmap to how you're doing things. You calculate the actual value by multiplying the numbers on top and dividing by the numbers on bottom. Make sure that your answers have units in them and that they're correct. They are the correct unit that is asked for in the problem. So here's an example. You have a 5-ounce steak. How many kilograms would it weigh? So the known is 5 ounces. The unknown is kilogram. You've got to figure out how to link ounces to kilogram. So you may know that 1 pound is 16 ounces. And you may also know that 1 kilogram is 2.2 pounds. So I have to sort of string this along in a way that makes sense. So my plan is to go from ounces to pounds to kilograms. If this helps you, great, use it. If it doesn't, don't worry about it. So I'm going to start with 5 ounces. So if I start with 5 ounces, I've got a single unit, and that is in ounces. So we were talking the other day about how we could take this information and we could either put 1 pound on top or on bottom, and 16 ounces would go on the opposite side. So when you're using that for a problem, you have to say, okay, well, I've got ounces, and keep in mind all this is over 1, so those are on the top. If it helps you to write that out, do that. That's fine. In order to cancel out ounces, though, I need ounces on the bottom over here, because what that allows me to do is this and this will cancel. So if those two things cancel, that means that I want to take this side and put it down on the bottom, and I want to take this side and put it on the top. So that's how I can sort of determine where it is to put my information that I'm given as equal. So in this case, I've now got 1 pound on top, 16 ounces on bottom. So these will cancel. Notice I haven't done a single thing with numbers. Not paying attention to that, just making sure that they're in there, so that 16, for example, goes on bottom with the ounces. If ounces went on top, 16 needs to go up top. So now I'm in the unit of pounds. So I look at the next piece of information that I have. I need to cancel out pounds, and keep in mind we're trying to get to kilograms. So this works because I can take pounds and put them on bottom. So this entire section goes down here, and then kilograms would go up top. So this section goes up here. Take that away so it's not in the way. In this capacity, pounds here and here will cancel. My units are all canceled except for kilograms, and that's what I want. So that's my goal. We're good. Now I put things in my calculator. And what I do is I multiply everything up top and divide by everything on bottom. So 5 divided by 16. Now here's where I would just go ahead and hit equal in my calculator and then put divided by 2.20. If you instead want to put in 5, you could then put in divided by, I would suggest putting in parentheses 16 times 2.2 in your calculator. That way there's no confusion and you're not multiplying by 2.2 by mistake. That should give you a very long number. So keep in mind, we have to use significant figures. The only significant figure you really need to worry about here is the fact that there are 5 ounces. Actually, I don't think that 2.2 pounds is an exact conversion there, but it doesn't really matter in this case because there's more significant figures there than in our original data. And so we have to round down, and our final answer should be 0.1 kilogram. Okay. You need to practice these. Everyone has to practice these in order to truly get it. So I will probably post a video of going through a worksheet or something to that degree at a later time. Okay, just to throw these things out there, we also need to know what density and specific gravity are. we can certainly use these topics as well when it comes to dimensional analysis. So density is defined as mass divided by volume. And that means it has two sets of units. Something to keep in mind there. Another equation for that would just be D is equal to M over V. So let's say we're trying to solve a problem. If an object has a density of 10.3 grams per liter, what is that in grams per milliliter? So this is another prefix types of problem. In this case, we don't have a single unit that we're starting with. We have two, because we have gram up top and liter down below. That just can't be avoided in this case. What we want, though, is for gram to stay there, because we're looking to go to gram per milliliter, and just convert the liter portion. So this is a backwards thinking in comparison to what we just did. We, instead of having to cancel what's on top, we have to cancel what's on bottom. So in this capacity, we need liters up top and milliliters down below. Now, this is a more rare situation, but I just want to show you that this can happen too. But because liters cancel out in this case, we convert that to milliliters. So that would be 0.103 grams per milliliter. I do have that in the correct number of significant figures because we have 3 here. And our conversion factor is exact, so we don't need to worry about it. Now, I'm doing this with a conversion factor where 1 milliliter is equal to 10 to the minus 3 liters. And I think that's how I gave it to you in previous notes. However, there are many ways to write these conversion factors. We could have instead said that 1 liter is equal to 10 to the third milliliter. Here's what you need to check. I think that in your brain you can say, oh, milliliter is smaller than liter, so we need a teeny tiny amount of liters to make 1 milliliter. True. Or on the bottom we could say 1 liter is much bigger than a milliliter, so we need 10 to the third milliliters for that. Also true. So make sure that the conversion factor that you're using is just consistent with what's in the problem. It doesn't really matter which one you use, because if you do it this way, you still end up with the same answer. So if you do use the 10 to the third milliliters instead of 10 to the negative third liters, the problem still ends up with the same answer. So don't panic over that. Also, especially in allied health, you should know this term called specific gravity. And that is a value that compares a substance, whatever that substance is, and its density to that of water. I didn't mention this, but density doesn't change for a given substance no matter how much of it you have. Just putting that out there. So specific gravity is the density of an object divided by the density of water. And since both of them should have the same units, it's kind of one of those weird things that doesn't have a unit because they all cancel out. But in general, if you have a specific gravity that's greater than 1, then that object is heavier than water. It should sink in water. And if you have a specific gravity less than 1, that object should be lighter than water and it should float. Okay, I'll see you on the next video.